Hello everybody. In this video we will discuss another problem to figure out which one of these alcohols. So we have ethanol on the left and we got tertiary butanol on the right, and we'll find out which one of them is going to be more acidic. So in this video we will discuss another effect called solvation effect. So this effect, it's basically telling us what is the effect of solvent is going to have on the acidity of corresponding alcohols. So we can figure out the exact same way. So first thing that you want to do is find out what is the conjugate base that's going to come out once you deprotonate our alcohol. So if we deprotonate our alcohol, O minus, so this is our acidic proton right here, and we have acidic proton right here. So once the proton is gone, we got this ethoxide ions, right? And then let's draw the structure that will form once we deprotonate. I'm drawing the full version here for a reason. I'll explain in a second. Okay, so right now you have both of the conjugate base. Remember the rule. What is the rule? If you haven't watched the previous part 1 and part 2 of this video, make sure you watch them. The rule is, if we can make this conjugate base somehow stable, like between left and right, whichever is more stable, the corresponding acid becomes more or stronger acid. Again, it doesn't have to be this side. If this conjugate base is more stable, then the corresponding acid will be the one that is more acidic. So let's find out why the structure on the right would be more stable, or structure on the left would be more stable. So the reason that happens is something called solvation effect. So what would happen when you have a negative charge on oxygen? Then your solvent will try to disperse that negative charge somehow. So every time you have something negative charge, let's say your solvent has slight polarity, it will try to align itself around that negative charge. So you can see it is dispersing, it's taking away a little bit of that negative charge, all those solvents. So these are your molecule of solvents. Now these solvents molecule need access to that negative charge, right? So solvent molecules is gonna align themselves with the negative charge, so that it will take away a little bit of negative charge away from the oxygen so that it can stabilize. Well, not taking out, they are not necessarily taking out, but they're stabilizing the negative charge on oxygens. That would be the right way to say it. Okay, so let's try to draw a similar scenario. What would happen with the solvent? So you noticed now the solvent does not have enough access. So if you notice on the structure on the right side, this is just a cartoonish diagram. So we got 1, 2, 3, 4, 5, 6, 7 solvent molecule is getting a nice access to the negative charge and stabilizing the negative charge on oxygen. However, here only 1, 2, 3, 4 molecules are getting access. You know why they are not getting access enough? So if you notice, so this one here, it cannot enter from this side like it did here. It cannot enter from this side because it is blocked by this steric effect of this methyl group. So because there is a heavy branching in this structure, the solvent molecule does not have enough access to reach to that O negative. It is blocked by the methyl. Again, it's blocked, not only blocked by on this side, but also it is blocked by, if it's tried to come from the other side, it is also blocked. So this tells us that the charge here is not very well. So the negative charge on this oxygen is not very well stabilized by the solvent molecule. So as a result, the structure on the right, the tertiary butoxide ion here, so this one is not very stable. And the structure on the left is more stable And why more stable? Because the O negative is stabilized by, more solvent molecules. So O negative is stabilized by more solvent molecules. So now if the structure on the left is more stable, what that makes us, let's say the structure on the left is more stable. So if the structure on the left is more stable, which makes us the structure, the corresponding acid is more acidic. And we can prove this by a number. The pKa of this thing should be around 16. Like it's around, all the alcohols are around 15.5, 15.7. The pKa of tertiary butanol should be around 18. So obviously we know that lower the pKa, more acidic something is. And we can prove this by the effect of solvents as well. So in conclusions, more branching implies lesser acidity. Okay, so if something is more branched, then the corresponding alcohol would be a little less acidic. I hope this makes sense. All right, that's all I had to say in this video.